Lesson 16, the hyperbola, part 1. A hyperbola is the set of points, locus P, moving in a plane such that the difference of their distances from two fixed points called foci is constant. You have point P on the plane, you have the two foci, F1, you have F2, you have the vertices, V1, you have V2. The distance between P and F1 is D2. The distance between P and F2 is D1. You have the directrix S equal to minus A, and the two other lines Y equal to B over A times S and Y equal to minus B over A times S. This is figure 11. The locus condition is that the difference between D2 and D1 is equal to a constant, that is PF1 minus PF2 equal to constant. You have them under the symbol of absolute value. When P is at V2, PF1 is equal to C plus A. PF2 is equal to C minus A. Therefore, this difference is equal to this. If you open the bracket, you have it in this form. C minus C is 0. A plus A, you have 2A. Therefore, this difference is equal to 2A. Recall that the distance between 2 points S1, Y1 and S2, Y2 is given by this formula. Let's consider PF1. PF1. S here represents S2, then C is S1. Y here is Y2, 0 is Y1. You have them in this form. This is S2 minus S1 in bracket square. Y2 is Y minus Y1, 0. So you have Y minus 0 in bracket square. That is Y square. If you consider P and F2, you have the distance between them. The difference is equal to 2A. You transfer the second term in the left hand side to the right hand side. You have it in this form. Square both sides, you have this result. The power of 2 will remove the square root sign from here. You have it in this form. If you expand this term, you have this result. Now, if you transfer this plus y square to this side, it becomes negative. So plus y square minus y square is 0. This term and this term, they are gone. You have this result remaining. You expand this term, you have this result. You come here and expand this term, you have this result. Now, if you transfer s square plus c square to the right hand side, it will remove this s square and this c square. Then transfer this term to the left. You have this one here already, then minus the second term that is coming in, equal to this result. If you add from here, you have it in this form. Divide through by 4a so that we have coefficient of 1 here. If you divide this term by 4a, you have minus cs over a. Divide by 4a, you have a remaining plus. Divide by 4a, you have this term remaining in this form. Transfer plus a to the left hand side, you have it in this form. To proceed, you have to square both sides again. You have the result after squaring both sides. If you expand this term, you have it in this form. The square will remove the symbol of square root. You are left with this result. When you expand this term, you have this result. These two terms will cancel off if you transfer any one to the other side. Let's move s and y to one side and the constants the other side. You have this result. From here, you can factor out s square. You have it in this form. You simplify this term right here as over 1. You find the LCM, that is a square. You simplify, you have this result. Divide through by c square minus a square. If you divide this term by c square minus a square, here becomes 1. You have it in this form. Divide this term by c minus a square. You have it in this form. You divide this term by itself. You have 1. Recall that b square is equal to c square minus a square. When you replace it, you have this result as equation 18 with major axis horizontal, or you have it in this form with major axis vertical. So equation 18 is the equation of a hyperbola in the standard form. Asymptotes of the curve. Consider the equation 18 again, that is this equation. The left hand side of the equation is difference of two squares. Hence, by factorization, we have this result. We divide through by this term. If you divide through by this term, you have this result. if you simplify the term here, s over a plus y over b, you find the LCM, you have it in this form. When you divide, you have AB over BS plus AY. Thus, S over A minus Y over B is equal to AB over BS plus AY. That is equation 19. Considering the right hand side of equation 19, this side divide each term by s. You have this result. As s tends to infinity, this term also tends to infinity. Also, you come here again, the same right hand side, divide each term by y. You have it in this form. As y tends to infinity, the right hand side of equation 19 also tends to infinity. So as s and y tends or approach infinity, the expression on the right hand side of equation 19 approaches 0. Hence, the expression on the left hand side of equation 19 must also approach 0 as s and y approach infinity. Thus, s and y approach infinity. For that reason, s over a minus y over b approach 0. The straight line s over a minus y over b equal to 0, or if you solve for y, you have y to be equal to b over as, is called an oblique asymptote. In the diagram we considered, you have this line y equal to b over as, y also equal to minus b over as. So we are trying to derive the two lines that we have in the diagram earlier. The curve is symmetrical about the s-axis, so the line y equal to minus b over as is also another oblique asymptote. End of lesson 16. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.